Hello, my name is Jake Kwon, and my slides are here. I'm here to represent Cosmos and Tendermint. And I'm really excited to tell you about what we've been working on for the past almost year. It's called the Cosmos SDK, and I want to tell you about how we believe that it's going to change the way that we engineer blockchains. So first I'm going to talk a little bit about how blockchains came to be. So just to provide some context. So first there was Bitcoin, and Bitcoin was unique in that it was the first widely distributed proof of work EFT ledger. But they were innovators in that front, and they kind of made this whole space come to be. But one problem was that the major Bitcoin client was a single monolithic software stack. And it was difficult to tease apart the parts of it to create your own blockchain application. So if you remember like Litecoin, Dogecoin, and Namecoin, these blockchains were more or less identical to the original Bitcoin system with very few modified functionality. And even if you look at Namecoin, it is a bit different, but it wasn't sufficiently good compared to something like ENS because of the lack of architecture modularity in the Bitcoin software stack. And then came Ethereum, the second generation of blockchains, and it was a radical departure from Bitcoin in how we develop blockchain applications. So with Ethereum now you can more easily create applications by writing Solidity and just uploading it to the Ethereum mainnet, which is amazing. But it still doesn't give you full control over the blockchain. So not many people actually modify the Ethereum stack. So for example, you can't do things like charge transactions using a different token other than Ether. And also the EVM virtual machine itself has certain baked-in constraints, like requiring a registry with 32 by 32 byte key and value pairs, which makes the whole thing a little arguably inefficient. But yet it was definitely an improvement. What we think we need is a new, a modular software stack that makes it both easy to develop on, safe to develop on, but also enables you, gives you full control over the entire stack. And so that's what the Cosmos SDK is there to provide you. So let's see how we do that. One, it's written in Golang. So Golang is Go is Google's language, and it's gaining wide adoption. It's an excellent language for developers of all experiences. It's got a great tooling system, and it has a rich ecosystem of libraries. So the idea is that by using Go, you're writing your blockchain application in a language that already has a lot of resources, and it lets you develop faster, and using the type safety of the Golang language, you can create more safe blockchains. Like, the idea is that if you remember when websites like the Web 2.0 revolution was happening, one of the key drivers behind the innovation in that area was website frameworks like Ruby on Rails and Django. And what we believe is that what's lacking today in this ecosystem is a good framework, software framework for developing these blockchains. So we're creating the SDK with that in mind to create a good set of libraries, a framework. So everything we write is open source. It's all available on GitHub. You can see our development there. And the idea is to create a rich ecosystem of libraries that you can draw into, not only from libraries that we create, but from libraries that others create to compose your blockchain in a secure way. So this is just going back to what I said. It's about modularity and it's about extensibility. We're trying to create an open ecosystem so that innovation in the blockchain space can happen faster. So let's take a look at some of the core modules that we have built and are still building. So the first one is the project that we started with, Tendermint. Tendermint is the BFT consensus engine for Cosmos. It started in 2014, and it's the most mature, advanced BFT engine available on the market today. And it's fast, so the consensus engine is no longer going to be your bottleneck because it's very fast. So to give you an example, every block on Tendermint commits to finality. So there's no, unlike in proof of work, there's no need to fork, there's no need to wait for an hour. So you can get a transaction that gets committed to finality on the blockchain. You can get a receipt, proof that that happened, all within a matter of seconds. And you know, this isn't just talk. We actually have a test net running with over 100 validators. Recently, at one point, we had 170 validators, and it was still committing blocks in over 5 seconds. So this is something new, and that's something that's never been done before. And finally, Tendermint is not only a mature open source free blockchain engine, but it's also formally verified or formally proven. So there's a new paper by Zarko, Buckman, and myself that proved the safety and liveness properties of Tendermint. Another module in the Cosmos SDK is the proof of stake module. So with BFT Tendermint, you get the qualities of security and accountability, but you know, proof of stake chains require more than that. It's about economic incentives as well. So using the staking module in the Cosmos SDK, you can create your own blockchain that can use your own staking token to create your own validator set. The validator set is like a mining pool set or mining set, except we don't use proof of work. Everything is done through cryptographic signing. And it's also designed to enable massive delegation. So while you only might have 100 or so, or if you don't mind the latency, you can have thousands of validators. You can still have massive participation and distribution, or decentralization, by using the delegation system in the SDK. So you can have 10,000 delegators, each delegating to validators of their choice, and everyone has skin in the game. So when you delegate, you earn a portion of the rewards, but when you're validated that you delegated to gets punished or slashed, then you get punished or slashed as well. So this is a new innovation for proof of stake. Here's another module. It's a governance module. So we believe that proof of public blockchains should have its own governance mechanism. The idea is that you can put a proposal on the chain itself, and you can have the stakeholders vote on whether to accept or deny that proposal. And you can see how that might have been very helpful in the case of something like the DAO hack on Ethereum, where the community was split on whether to reward the hacker or to refund the original token holders. By having a governance system on-chain where people can actually discuss and vote, it's completely feasible that the Ethereum hard fork or the Ethereum Classic will never happen. So our governance proposal system allows for arbitrary human language proposals. So if you want to have a constitution and modify that, that's a great way to do it. But it can also be used to automatically change the parameters of the chain, and of course it can be used to upgrade the chain itself. And of course, the delegators get a vote as well. It's a lot like liquid democracy, if you've heard of that. It's where you basically, your representative validator, you inherit their vote unless you want to interject and you want to vote differently. And here's another module. It's the reward and fees module. This lets you distribute rewards and transaction fees to the stakeholders and the validators and delegators of the blockchain. The nice thing about this is that you can use this to accept transaction fees in any token. So it doesn't just have to be like one Ether token for gas payment. You can really let anyone pay with any token. So imagine that. When you don't have to buy a blockchain's native token in order to use it, it'll increase adoption. And finally, the most important piece of the core SDK module library set is the IBC library. This is like, I'd say that today, blockchains are like what computers were like before the World Wide Web. So you have like Bitcoin and Ethereum, but these two blockchains are not able to talk to each other because there's no TCP/IP World Wide Web connection. And the idea is that by building your blockchain on the SDK And just by importing the IBC module, you can communicate securely. Your blockchain can communicate securely with other blockchains. This will enable massive scalability by having many parallel blockchains that are coordinated by something like a hub. So IBC, you can think of it as like a network interface for a blockchain. I want to tell you about some of the blockchains that are being built now on the SDK, just to show what it's like. So of course there's the Cosmos Hub. We're launching the Cosmos Hub soon, and it's essentially using all the core modules of the SDK. And in addition, there's a new module that will bake in called PEGI. The idea is that the Cosmos Hub is a proof-of-stake blockchain that connects to many chains through IBC. So if you build a new blockchain on the SDK, you can connect it to the Cosmos Hub and thereby get token and data interoperability. And of course, PEGI is a module that is used to not talk to new SDK chains, but legacy chains like Bitcoin and also newer proof-of-work chains like Ethereum as well. So the idea is that the Cosmos Hub becomes an inter-blockchain highway that enables massive scale and interoperability. Here's another blockchain being built on the Cosmos SDK. It's Ethernet. So Ethernet takes the same modules as the Cosmos Hub, but it also has the EVM module. And so it's a completely compatible EVM system, so your smart contracts will also run on Ethernet. So that's easy to understand. Shared security is interesting. Shared security is the idea that you can have multiple parallel blockchains that are being secured by the same validator set. So you can imagine that with shared security and the EVM, so Ethernet connected to the Cosmos Hub, you can actually have multiple Ethernet instances that are sharding out the computation being done on smart contracts. So this is a way to scale Ethereum smart contracts. Iris is another blockchain being built in the Cosmos SDK. You can think of it as a regional hub for China and the greater Asian enterprise market. The idea here is that, kind of like what Vitalik was saying, not all of the computation for a blockchain should or needs to be on the chain itself. And what you can do is create an interface layer that allows for off-chain resources and computing to be coordinated through a blockchain. And so, Iris, their goal is to help enable this, the innovation of the blockchain ecosystem by bringing off-chain resources onto to be coordinated by blockchain, but also coordinated among multiple heterogeneous chains through IBC. Lino is a new blockchain being built on the SDK, and it's about distributed video streaming. So it's kind of like YouTube on a blockchain. And so they need to use a lot of modules. For example, the reputation module would be one that they can use to incentivize and reward the best video producers. And of course, they can also use the microservices module. This is theoretical. I don't know if they're going to do that, but they could use the microservices module to, for example, find video hosting services. Kava is another blockchain. It's a payment channels module being integrated onto the SDK, as well as it provides interledger support, so IoT protocol being implemented along with payment channels on a single blockchain. So you can imagine the Kava blockchain being connected to the Cosmos SDK, providing high-scale transaction throughput with the help of things like payment channels. Fourth State is another blockchain. This is about plasma Ethereum sharding. So the idea here is that using the PEGI module, which I mentioned earlier, it can connect to the Ethereum mainnet proof-of-work chain. And using the plasma module, it can provide secure recovery in the case of blockchain failure. So the idea is that you can build plasma child chains using the SDK connected directly to the Ethereum mainnet. So there's a lot of things that need to be built. We believe that what is needed is it's a framework for creating these modules and a way to make them all interoperable. Think about what you want to build and see if you want to build it on the Cosmos SDK, because as an engineer, I believe it's the best place to build these new complex applications. And of course, the idea is that by building on the Cosmos SDK, you leverage a network of blockchains. For example, the Cosmos Hub doesn't have to be at the center, but as an example, they can all connect to the Cosmos Hub, and the Cosmos Hub will provide that interoperability layer so that you can move tokens between blockchains. So you can move your Lino token over to Kava, use it as a payment channel, and so on. So with that, I just want to say, just re-emphasize that we think what this space needs in order for the next layer, the next wave of innovation to come, is for us to have a solid framework for blockchain development with a growing ecosystem of libraries and modules that work well together. So please visit the QR code over there, or it's cosmos.network/GBS, and we will give the first 5 registrants early access to our technical SDK newsletter. So please do that. Thank you.